Hello, everyone. This is Professor DePaulo. Welcome you back to Psych 220 Behavioral Statistics Lab. And today we're going to be talking about the one sample t-test, SPSS Lab 5. So, how do we do the one sample t-test? Well, we have to differentiate it between the one sample z-test and the one sample t-test. So, the one sample z-test can only be used when we're comparing a sample mean to a population mean and we know the population standard deviation. So to use the one sample z-test, we must know the population standard deviation. If we do not know the population standard deviation, and we're comparing one sample to a population mean, and we don't know sigma, we don't know the population standard deviation, we must use a one sample t-test. And in most research contexts, we do not know the population standard deviation. We'd have to be doing something that's been extensively studied. We'd have to be looking at something that we've been studying for years, historical data, stuff from like the census, maybe. Most of the time, I would say in 95 to 99% of the time, we do not know the population standard deviation that we're going to compare our sample mean to. So we have to use a one sample t. In this problem, previous research has indicated that the typical blood pressure lowering drug reduces a patient's blood pressure to 135 systolic. The following hypertensive patients have been treated with a new investigational blood pressure pill. And we are claiming that the new drug will lower blood pressure readings. So we're going to test this claim. We do not know sigma. We know the mean we're comparing it to, which is 135, but we do not know the population standard deviation. So we must use the one sample t. So to use the one sample t, we're going to enter this data into a column in SPSS. Let's see if I can copy and paste it, which I may or may not be able to do. And I was able to do that. So we have 16 participants. We're going to call this blood pressure. All I did was double click here to edit this. Call it BP. And we're going to test this hypothesis against a mean of 135. So the null hypothesis is that there's no difference between this sample with the new drug and what we got previously in terms of blood pressure. The alternative is that this drug lowers blood pressure. So it's directional hypothesis, one tail test, and it's going to be lower than 135. So we're going to compare this sample to 135. So let's do that. Analyze. Compare means one sample t test. We're going to compare blood pressure test variable to 135. And we don't need effect size for this. I mean, you could have effect size. We don't need to have that right now. Make sure that you have this, leave this alone. BP to 135, hit OK. We've done our one sample t test. So the mean of the sample is 116.5, and we're comparing it to 135. So is this mean of the sample less than, significantly less than 135? As you can see here, we have a massively large t-test, t-value. If you look at the one-sided directional hypothesis, p is less than 0.001, which is way less than 0.05, so we reject the null hypothesis. This is a very large value. There's a huge difference here. The difference is 18.5, which is a massive difference. And we're looking at this one-sided p for directional, less than 0.001. That's much less than the alpha value of 0.05. So we're rejecting the null, and we're concluding that the new blood pressure pill is better or works to lower blood pressure compared to your typical blood pressure medicine. So in other words, it's better than the new pill is better than the traditional blood pressure medicine. It lowers blood pressure more than the traditional blood pressure medicine. And that's it. And then when you're writing this out, like if you're reporting it based on based on what we have here, you're gonna write. Let's see if I can write it out on in Word here. So this is a significant result. So how are you going to write it out? So you put T, and then you put in, that should be lowercase t, by the way. I know it's auto correct. T, and then you want the degrees of freedom. Degrees of freedom here is 15, which is n minus 1. So we got T, and then we got 15. So that goes in parentheses, equals the actual T value, negative 9.221, comma, and then we want the p-value. P is less than 0.001 here. So we say there's a significant difference, and this is how we would report it. It's important to know all these components. The test, the degrees of freedom in parentheses, the actual t-value, and the p-value, the significance value. So this is basically rejecting the null hypothesis, and that the new pill is superior in lowering blood pressure compared to the old pill or the old medicine, traditional medicine. And that's it. That's how we report it. Now let's take a look at some other problems here. This is Tom's Luncheonette. He advertises it takes 20 minutes to be served, an average of 20 minutes to be served at Tom's Luncheonette. That's pretty damn good. A competitor of Tom's Luncheonette disputes this claim, saying it takes more than 20 minutes. So once again, it's a directional hypothesis greater than 20. And we took a sample at Tom's Luncheonette and we're comparing it to 20. So is this sample going to be longer than 20, greater than 20, significantly, or is it going to be 20 or less? So let's take a look. We're going to have to actually input this into SPSS. You can't copy and paste this. So we're going to input into SPSS here. So let me open up SPSS. Here's the SPSS. And let me close this out. Let me get rid of this for now. Let me clear this out here. And we're going to put the new values in here. And you can't really copy and paste it. So I'm going to just have to copy it. 25, 18, 23. Oops, 25 didn't get registered here. And that's not right either. So that's a one thing here. 25, 18, 23. It's very easy to make a typo in these things. Get rid of that. 25, 18, 23, 15, 19, 16. What else do we want? Let me close that. 27, 18, 24. 21, 17, 16. 22, 24, 21. 19, 16, 18. 23, 18, 19. 25, 27, 18. So we have 24 data points. 1, 2, 3, 4, 5, 6 times 4 is 24. Okay. We're comparing this. This is going to be wait time. So I'm going to just call it time. Call it time, for lack of a better word. And we're going to test this. So analyze descriptives. I'm sorry, analyze compare means. One sample t test. So time we're comparing to a value of 20. So the null hypothesis is that it's going to be 20 or less. The alternative is that's going to be greater than 20. So we're a competitor with Tom's Luncheonette. So we want Tom to be wrong about his luncheonette, and we want it to take longer than 20 minutes to get served. 20 minutes is pretty quick to get served lunch. Let's check this, hit OK. And as we see here, our t value is 0.504, our degrees of freedom is 23, and our directional hypothesis p-value is 0.310. So this is going to be a fail to reject the null. So we're going to fail to reject the null, and that's bad news because we wanted to reject the null. We wanted this to be much more than 20 minutes for the wait time, and it happens to not be significantly different than 20 minutes. So I'd write T 23. Let me see if I can write that up. So for this one, it'd be T 23 degrees of freedom in parentheses, and then the value is 0.504. So 0.504, and our p-value is not good here. It is 0.310, one-tailed test. 0.310. And this would be fail to reject the null, and it doesn't take longer than 20 minutes. So Tom is true to his word. It's taking on average 20 minutes. And this sample of people from Tom's Luncheonette does not dispute that, right? So we fail to reject the null, and we say that it doesn't take longer than 20 minutes to get served at Tom's Luncheonette. And that's it for the one sample tests. Hopefully that's pretty straightforward. Let me know if it's not. And then we'll be talking more about independent groups and then paired samples in the future labs. Bye for now.